All right, so thanks for everyone joining in. What I'm going to go over today, as Matt mentioned, is the Condor series of radios, a reboot showing what the existing feature set is, and then go over some new features, and then at the end, go over the 12 applications. So the agenda is that I'm just going to introduce, go over some deployments of really the industries, the Condor line product portfolio. As I mentioned, the existing features, new, and then those applications. So as you guys know, and if they have any new people on, we've been in the industry for about 40 years. So we are an expert on wireless communications and have a lot of different products across different frequencies to offer. So I am out of Louisiana. I am a support engineer and in sales, and then the same thing with Matt out of Tampa. He's more sales, doing support. We do cover the Americas. We're based out of Australia, and just for everybody to hear for support through me, because it's in Australia, I send off if I can't answer the question, I'll send off an email. At the end of the day, their day is beginning, and I usually have the answer by the next day. So across all of the different industries, we do focus a lot on water, but we can get into a lot of oil and gas that require the Class 1 Div 2 rating. And as you'll see in a few of the applications, new applications, we're going to be able to communicate HARP. So as a summary, across the line of Condor, we can communicate long distance Wi-Fi, licensed free non-100, and licensed 152 non-100 megahertz. Our product can be point-to-point, multi-point I/O. The radios can be a gateway I/O and also a repeater. We do use a Pro Mesh network that is a repeater to itself, so all the radios can have repeaters to themselves and create a mesh network. We go up to 256 encryption for security, and then also we had the protocol converter to where our base unit is Modbus, but then we can communicate out Modbus TCP, RTU, DNP3, and also MQTT. As far as expandability on I/O, we have the capability of expanding to more digital inputs and analog digital inputs and outputs and analog inputs and outputs. So as a product range, the 215 is the Wi-Fi version. The 925 is the unlicensed 900. 415 is the licensed from 150 to 900, and we have a ultra low powered unit for that as the 415U1. What is not added is the 115E2. It has all the capabilities of the I/O, the communications and everything, but it does not have any kind of wireless in it. And then as you see at the right, we do have cellular modems. So it's showing the IoT gateway one, which is a 641M. We do also have a 645M that is more of a pass-through, not a gateway. So features, we do have the protocol converter, cybersecurity, and then in the new features, we're expanding more on securing the network. We do have simple logic and a simple HMI called the dashboard. So with the security, we do have 3 levels of user access control on top of the encryption of 256-bit. With the communications, as I mentioned, we're based off of Modbus, but we can convert it into DNP3 and MQTT at any node. and the features of the dashboard and the logic, where on the logic, it's very simple logic. It's not a PLC replacer. It uses statementless, so you can just modify and do like a little bit of conversions and conditional logic. So as a summary, you have that licensed and unlicensed, from Wi-Fi to 900 unlicensed, and then 150 to 900 licensed. You do have the I/O, where you have the 8 DIOs, where some of those are pulsed inputs and outputs. On the analog, for the 4, it's 2 analog inputs that can be 4 to 20 or voltage, and then 2 of them that would only be 4 to 20. On the analog outputs, it's only 4 to 20, and you have those expansion modules. So the HMI light dash, the security, as I mentioned, we do have a lot of diagnostics built into the radio. We're certified for Class 1 Div 2. The power, we were able to connect a battery to it. Also a direct connect to the source, and have a UPS connect to the battery. But then you can also connect with a solar panel. You have that protocol converter built into it. So like I mentioned, we're based off of Modbus, and you can get out the information DNP3 and MQTT. And then I have that what we call Logic Light or IO Plus. So within the configuration, you have the software called cconfig, and then you can also configure it by a web server. And this is where you would be able to also get some diagnostic information, actually through both of them. So this is just showing a program structure where all of the radios has this radio port except for the 115E. And as you notice, it's all the IO and communications is connected to a registers based off of Modbus. And that is why we are able to pull in IO and communications, put it into these registers, and then be able to data convert it out different protocols, even over the air. So it's very, very powerful. So as for the wireless, as I mentioned, they have that Pro Mesh. So each radio can be a repeater to itself. If you need to create a actual repeater that's its only function, you could do that within this mode. And then you also have a manual mode to do anything you want. But majority of everybody uses the Pro Mesh because it automatically does it for you. So within here, it's just showing you the different IO that I already went over, and then communications. And then over the serial port, it does have that expansion port, which also powers the devices. So it has the communications, and it powers the actual expansion modules up to a certain amount of them. I think it's up to 10 of them. So this is other area to where you have user-defined Modbus registers, different types for discrete, word, or actually float, that are able to be used at your leisure for any kind of application. Here's just showing you all the communications, where I mentioned the DNP3, the MQTT, Modbus, and what we have done, and it's going to be one of the last slides, is we are able to add HART in this area. So I'll wait until I get to that to describe that. Within the software, there's a fail-safe block. The reason why I'm showing this is a lot of people use this. Well, we use this to actually create a comms fail for each one of the remote radios to let you know when the base radio is not communicating to that remote. But you can also use this block for any of the IO. for discrete or analog. Same thing with the software. We have a sensitivity block. This is mainly for analogs to where you can improve a network's bandwidth by modifying the sensitivity. So for example, with a float, you're doing a decimal value. So if it's changing beyond the decimal, it's being actually sent over the air. So to prevent that, especially on large systems, to improve your network bandwidth, we allow you to adjust that sensitivity. The default is 3%, but you can modify it to whatever you need to make the network more efficient. Communications, this is where you would set up communicating to the expansion IO or a Modbus RTU slave or master. This is showing you on Modbus TCP. And this is one of the new features built into this area for TCP, where we are using UDP to where you can also improve your network bandwidth. And there's going to have a new feature or option within here for HART. And I'll show you that in the one of the last slides. But that HART protocol is in alpha firmware testing. So I'll explain that, and then later when we open it up, if y'all have interest in that, we're looking for people to test it. So this is just showing you the dashboard where you can go up to 50 of these blocks, and this can be referenced to any one of those addresses that are in our registers, our data registers. So where you can have a window in to the radio for diagnostics, or if you wanted a little simple HMI. This is where you would go into and do that logic statement list. So you have if, then, else, and mathematical instructions that are statement lists. So new features. This is a feature, but it was a fix of an issue where the internal fuse in some installations was blowing. So what we did is we replaced that fuse with a 10 amp slow blow, and it solved the problem. So majority of everybody's fine with it, but they had some issues, and we fixed that in the last rev. So this bulletin 132 went out at the beginning of December of last year. So and as you see it went through the whole range of the Condor radios. So we fixed that issue. So if you are having issues with older ones that fuse is blown, let us know, and then we'll be able to help you replace that. Software additional features, as I mentioned, because our radios communicate over the air Ethernet, we had a very large install for hundreds of remote radios in Saudi Arabia, and we were having issues with using up the bandwidth. So what we did was improved, or actually changed the way we sent the Ethernet messages, and did it by UDP rather than TCP, where really what you're taking out is the error checking and doing core communications over Ethernet. And if you don't get if the remote does not get it, it's sent again. But it doesn't go through the error checking, which saves you a lot of bandwidth. We do have encryption codes over the radios. We did add being able to upgrade the firmware over the air. And then the last two are more for Ethernet for security, where we have it to where they have MAC IP filtering with white and black list, and then also port forwarding. So if you have any applications that need that, I can work with you offline, because that's more of these are more advanced features. So for applications, I'm going to start with more simple to more complex, and these could be applied across any industry. And some of them at the end is more for when you have a heart instrument, which usually is in oil and gas, petrochemical, in plants, or really anywhere that you communicate with heart. So for the first one is more of just going from a PLC or DCS with hardwired I/O. So with our radios, we have I/O built into the front of it, and we have the expanded I/O to where you could go from any remote to the base, or any remote to from remote to remote, and send I/O. And you do that with the software to set that up, the I/O mapping. So that's really a real simple one. This is where you have the old 905s, where you have the 904 gateway as the base, and then you have the remotes that are 905 1, 2, 3, 4 that are communicating I/O. Where in the 905 world, you had the difference between a gateway and I/O module. But because we have built, into the Condor line, it can be a gateway and an I/O module. So within, another application would be being able to communicate to the remotes with I/O, but then the base radio, I want to communicate to a PLC or DCS, or even just directly to an HMI via communications. So we can do that via serial or Ethernet Modbus, but then also, as I showed before, DNP3 and MQTT. So with pulsed inputs and outputs, there's different applications for that. The two that I have come across, and I kind of didn't believe it, but you can do it with our radios because they're very fast. You can actually send a pulsed output to a remote radio, and then be able to pulse like a VFD to control a pump. They had one application that was doing that, but it was more in the water industry. A lot of petrochemical will probably not approve of doing that over the air, but you can do it with our radios. I helped somebody with that, and it worked fine because it was two devices. If you have hundreds of devices, we may not have access to that full network bandwidth, but you're able to do that. But then another feature that you usually would need to have a device to do this, but we can bring in a pulsed input from like a turbine flow meter and do a totalizer, and then bring that into that local remote radio, or pass that over to the base radio, which then can be displayed on an HMI or be used within the DCS or PLC. So those are the two key, applications that I have seen through my 1 year with the company, but you can really do anything with this, with all the analog. But it's nice to have the capability of doing pulsed ins and pulsed outs. So this is more of a larger system that is using all the features, where we have a remote radio that's just communicating to an Allen Bradley PLC, and it's bringing in I/O. So it's doing the gateway and I/O. This is just bringing I/O in. You guys are doing the same thing with Allen Bradley, bringing the information off the PLC and I/O. Over here, I'm writing out to a device, but then this guy right here is doing all three functions, to where it's the gateway communicating to this right here, which is expanded I/O. It's also bringing in I/O, and then it also is a repeater. And this guy is more of a gateway to interface to most probably a PLC or HMI. To add to it, you can add MQTT to where you can communicate up to the cloud, or remote or locally to a SCADA system, for example, using Ignition. We just finished a project similar to this using MQTT because within Condor, we can do 4 MQTT clients, and we are communicating locally to a ignition and then also up in the cloud. And we will be writing a business case scenario. Well, actually, Matt is doing it right now, to where if you guys want to look at it, we're going to be posting that on our website and then also on social media. So it's using MQTT that we have within our radios. So same thing. This is using our cellular modem, being able to interface to the cloud via Ignition or VT SCADA or other MQTT clients. And what you can do is, let's say you have a remote tank, you want to be able to pull that off and be able to look at the IO, communicate via Ethernet, or you have expanded IO. You can communicate that to our gateway because our 641M can pull in Modbus TCP and also Modbus RTU, do what is called a MQTT transport, and then transport that information to a broker up in the cloud for really anybody to see it on a computer, a smartphone, or a tablet. So we're able to do that. And notice this is the 115E. It doesn't have the wireless. So if you have a small system that has IO, you can also expand it with the Modbus RTU or put more Ethernet modules. And I don't show it here, but you could actually have, it's actually in the previous slide, you can have a wireless base radio and then communicate into remotes and bring it into the modem or the IoT gateway. This is something that I'm about to test and show functionality of this, because we do have the capability of going through the air and being able to send a serial or Ethernet connection like if I was connected directly to the end device. So we have the capability, even through the internet or the cloud, we can make a connection, a secured connection, because within our modem, we can create a VPN, and I can pull up the configuration software on the computer anywhere in the world, make the connection, and be able to communicate to that remote device. So I'm just showing you a flow computer, but this could be a PLC, could be really anything. We have the capability of making a connection over the air. And when I get to the heart, we're not doing it through the internet, but we're doing it locally through radios, and that's how we're able to do asset management using Packware. But I'll show you that in a little bit. So this is something that I'm actually going to do at a customer's site tomorrow. I've been working on this, and what it is they have it's off the Mississippi River, 2 petrochemical plants. One is supplying, well, both of them are supplying each other chemical from pipelines. So on this side, it's a pipeline coming in. This side is actually processing the information and then sending that chemical over to the customer, and they literally have a road in between. So what they want to do is they have a flow computer interface to their DCS. On this side is a Foxborough, this side is a Delta V. It's bringing that information in, and then it's communicating to our radios via a floating point, and then passing that over so where each customer knows how much of the chemical they're using for billing. Right now they're manually doing it, but once this is working, they can do it by reports within the DCS. And what problem they have is they this customer here is very, very stringent on their cybersecurity. So they will not allow Ethernet to go over the air. They need to break it down to a serial connection. So what they have right now is a Phoenix contact data converter that they never got to work. It's hard to look at it because they don't have a window into it. So what I'm going to do tomorrow is replace that Phoenix contact with a 115E that has the data conversion, but it has this dashboard. And what that is going to allow us to do is be able to do two things. See the communications, because right now we can't. It's holding up because of the way that this Phoenix contact is configured. So it's used as diagnostics, but then also it could be used as a backup for the HMI to see that the data is coming through. So that is a feature that we can use within our radios. The cost of that compared to the Phoenix is very close cost-wise, but it has much more power in our solution with the 115E2, especially with this data, this dashboard. I don't know of any data converter that has a dashboard like we do. And it just helps out because what I was trying to do with the Phoenix is use simulation software, connect to the serial connection here with a modem and be able to create my own on a computer, but it's done internally to our device, our data converter automatically. You just have to configure it. So this is jump into HART. This is a application right now that we're working on with a customer that there's two ways you can look at it, is a gateway only, or like I'm going to show on the next slide, be able to communicate over a network of radios up to around 60 of them, the way you could do these features. So what the features are is within our Condor. Right now, we're testing it on an ON25, but it's going to be available on all of our Condor radios. Is on the RS-45, we wrote code to communicate HART to a MUX, a HART MUX, which has 16 channels on it that you can connect 16 HART devices. And if you know HART, there's two modes. You got data mode and you got asset management mode. So for asset management mode, as I mentioned before, over the RS-232, the RS-45 configuration in the radio, we added a selection for HART gateway. And what that does, it automatically interrogates over the RS-45 HART connection to the MUX, and it tells you if the MUX is connected, for one, and then it goes out and it detects how many channels have a device wired to it. Once it detects that, then it goes further and says, per the HART spec, what manufacturer, what type of device you are, and then I want to gather the data from you, which would be the 4 to 20 milliamp signal to it, and then those four variables, the PV, SV, TV, QV. And what we do is automatically put that in registers within the Condor radio. But with the asset manager, we do, right now we have tested with Packware. We create, because the connection here is serially, we have to run a software package to convert that serial port to an Ethernet port. So we're creating a virtual serial port. Because our radio communicates Ethernet, we connect to it. It goes through the MUX to the end device, and it allows you to configure it and also calibrate it using Packware. The other, well, going to a more advanced system to where you have remote radios, this same functionality can be done over a network of radios. So that is in more of an alpha firmware set. We're actually going to be adding some diagnostics from a meeting that we had last night. I am going to be getting one of these muxes from MTL, who is our end customer right now for this project. And I'm going to be testing it with, I have ENH sensors, also with Emerson, Honeywell, Yokogawa, and start testing everything to where we can communicate and verify that the code that we have meets totally the latest version of HART. Another module that we are at the end of developing, and we should have it ready at the end of February, and we were talking about that last night, to be able to do the same functions as I mentioned with the data mode and also the asset management mode, is to have locally a radio that will bring in wireless HART information from devices into our radio and act the same as I just described here, where puts it in registers, and then it also allows you to use a asset management software to interrogate it to be able to configure it and do calibration. And that's more of a gateway standalone, but then you can do that same thing where you have remote connectivity to it. And that's it. So if we want to open it up for questions, I can answer some. I guess we have about 20 minutes or so, 24.
I've not seen any questions come over on the via the GoToWebinar site as of yet.
Okay. Well, as you see, it's a powerful radio. The next webinar, we'll be going over the HART, the hardwire HART as I described it in detail. I'll have my demos and be able to show it actually working and how to configure it. And then the following after that will be when the wireless HART one is available.
Questions, anyone? Okay.
Yeah.
That don't see any questions coming out. So.
All right. Well, if you guys think of any other questions, just send them to us, and we can answer them as they come in. Or if you have any kind of applications, as I showed, I can help design and spec out and help with the configuration of it.
There has been one question about the presentation. We will be able to, once the recording is edited, and it will be posted to the ELPRO YouTube channel, hopefully within the next week or so. Okay.
All right.
All right. Thank you all. Appreciate it.
Yeah.
Have a great day.
Thanks for y'all's time.
Yes. Look forward to working with you all. Have a great day.
Have a great